Welcome, Algebra 2 students. We are in Lesson 60. We're going to talk about direct and inverse variation. If you remember that from last year, it was kind of fun. When the statement of a problem says that A varies directly to B, or as B, or if A is directly proportional to B. We're looking for that word directly. When we see that word directly, then that tells us that we're going to use this type of formula. A is equal to K. K is our ratio. It's our proportion. And then B. So whatever the first thing is, varies directly means equals K times B, whatever it might be. So for instance, if I had the number of boys, right, varied directly to the number of girls. That'd be my formula. Or I could say the resistance, we'll just call it R, is directly proportional to length. You could see how that is kind of the standard whenever you hear the word directly. Okay, it's equals K times B. We have another one. The water produced varied directly, so we put in our ratio, as the amount of hydrogen burned. So hydrogen burned. Okay? So you could see how to put together a formula that uses directly proportional. All right. So we look for that first. We look for the word directly. Now we can look for a different word. We have a different formula for that, and that is going to be inversely. So when A varies inversely to B, or as B, that inversely word is what we're looking for. Or we could say that A is inversely proportional to B. That inversely is our clue that it's going to be a ratio on a ratio. So it's going to be A is equal to K divided by B. And you can remember the difference in the equations like this. A is equal to K directly multiplied to B. So K and B are in direct contact with one another, and they're being multiplied directly across, right? However, when we have inversely, K is inverted on top of B. It is an inverse operation to the original formula. This is multiplication, and the inverse operation of multiplication is division. So direct contact, which multiplies, inverse operation, which is division. If that helps you to remember directly and inverse and the formula that goes with it, then that is good. So here's some options, or here's some things that we have to try to figure out. The price P varied inversely as the number. The number of revolutions per minute, so revolutions per minute, is inversely proportionate to the number of teeth. So it's supposed to be a little t. So you can see how to set that up. K is your constant. K is the ratio that drives the value of either one of these variables. We have to determine what the variable is, what that K ratio is, and how it is like a proportion all by itself, right? It's like a constant. So let's look at some example problems so we can get an idea. We can wrap our head around this a little bit better. I'm going to take a moment and type the problem for us. All right, so problem 60.1. The number of boys in every classroom of a school varies directly as the number of girls. So there's our clue right there. So directly tells us we're going to use A equals K times B, right? So it looks like our A here is going to be boys, and then we're going to have girls. So B equals K times G. So in one room there are 8 boys and 2 girls. So we know these are factors, so we can divide by 2 on both sides. And we can find that K is equal to 4 for this problem. So now it tells us if there are 5 girls in another room, how many boys are in the room. So we're going to find out how many boys there are. We take our constant K, and we plug that in, and that's going to be 4. And then we take the number of girls in the next room, which is 5. So that tells us that there are 20 boys and 5 girls in another room. So there are 4 times as many boys as there are girls in every room. So that is how we would answer that problem. So let's look at another one. Let me clear this. Take your notes. Be sure to take your notes before I clear it. You can pause. All right, I'm going to take a moment and type the next problem. All right, 60.2, and I forgot to type my number. 60.2. The number of revolutions per minute varies inversely. So inversely tells us we're going to use A equals K over B as our formula because it's the inverse. All right, so the number of revolutions per minute, that's RPM, varies inversely as the number of teeth in the gear. So number of teeth. If, okay, now we get to filling it in. If 40 teeth is the result in 100 RPM, so we have 100 here and we have 40 here, right? Let's find our ratio. That's going to be, we're going to multiply both sides by 40. That's going to be 4,000. These cancel. This is K. So our constant is 4,000, right? If 40 teeth result in 100 RPM, what would be the RPM? So we got to find the RPM if the gear had 30 teeth. Okay, so 4,000 divided by 30. So we just whip out our handy dandy calculator and we say 4,000 divided by 30. And that's 133 and a third. You could write that as 133.33 repeating. If you don't have that symbol in Jupyter, what I'll probably let you do is just do 133 and 1/3. So you don't have to worry about looking for that repeating symbol right there. Okay? And that would be 133 RPMs. All right. let's look at our last example problem. Not a whole lot this time. So 60.3, I'm going to type that for you and then you can solve it. All right. The number of clowns was directly proportional to the number of performers. If there were 40 clowns when there were 20,000 performers, how many clowns would there be if there were 12,000 performers? So first, let's set up our formula. I'll tell you what, I would like for you guys to pause this video first, see if you can solve this one, and then come back and compare your answer and see where maybe you get it all right, maybe you just missed something, but see if you can do it for me, and then we'll go on from here. All right, if you got the answer that there would be 24 clowns if there were 12,000 performers, good job. That is the correct answer. So how did we get there? If you didn't get 24, let's go through this so that we can see where you made a mistake. So the number of clowns was directly proportional to the number of performers. So C equals ratio of K, or constant K, times P. So the number of clowns was 40. If there were 40 clowns when there were 20,000 performers, how many clowns would there be if there were 12,000 performers? So we divided both sides by 20,000. We got 0.002 is our constant. That's our ratio that we're going to multiply by. So we put that in place in the new formula. We're looking for how many clowns. So we put in our constant, and then we put in the 12,000 performers that we knew we had. And we just multiplied 0.002 times 12,000, and we got 24. So pretty straightforward. As you can see, it's not a whole lot of math. It's just knowing how to put it in the formula. And once you know how to put it in the formula, consistently solving it through to the end. Okay, remembering that this then turns around and gets subbed back in. That's all this is subbing it back in here for that K with the new number, whether it's this number or this number. You're just putting it in so you can solve to get the answer. And that's all we have for lesson 60. I'll see you ladies in lesson 61.